Hello, and thanks for clicking on this next Pre-Narculus production. Today, we're going to be talking about angle measures, different ways to measure angles. We already know one. We work with it all the time. We've worked with it since geometry, measuring angles in degrees. But there is a second way to do that. We're going to use radians today as well, and we'll take a look and see how the two compare and how we can go from one to the other. Okay, so let's get started. And we're going to get started on our real trigonometry adventure. So, angles. What we're going to do here is we're going to talk much more about trigonometry. To do that, the idea is that we are going to create triangles, make angles on the coordinate plane, okay? Which we all are familiar with, right? But the coordinate plane has some intricacies to it, okay? Things like, well, if you're in quadrant 1, the x is positive and the y is positive. If you're in quadrant 2, the x is negative and the y is positive, right? And those things are going to come into play as well as we actually go through this, all right? So we need to start with some definitions as to how to define angles if we're going to talk about the coordinate plane. So, every angle starts with its initial side on the positive x-axis. So this is the positive x-axis, right? There it is. It goes to the right. Okay, this is the initial side of that angle. There it is. All right. And its vertex is at the origin. The vertex is where the two rays, come out from. This is the vertex here. Then we move from there to create the angle. When the vertex of the angle is at the origin, we say this angle is in standard position. So from here, we can move this way, but keep in mind, you technically could also move that way, right? We can move either direction. And in math, we have a way to distinguish between those two, okay? If an angle is positive, we sketched counterclockwise from the initial position. So if from that initial position, we go counterclockwise against the clock, this direction, and draw our other ray up here, this angle would have a positive measure. And this side is known as the terminal side. Let's write it a little bigger. It's the terminal side, the side where the angle terminates, ends. Okay? If an angle is negative, here's our initial side, positive x-axis. Then we sketched clockwise from the initial position towards the clock's direction. So here would be my terminal side here, and this angle is what we traced out. Okay? All right, so let's just get the hang of drawing some angles. Let's sketch the angle 210 degrees. So here's our vertex. Here's our positive x-axis. That's where we're going to start from. And now we want to go 210 degrees around the coordinate plane. Well, if we start here, we're going a positive angle, so that's going to be counterclockwise, this direction. We know that this is 180, right? Think about it. It's half of the circle, right? Half of a circle. So it's 180 degrees, 360 degrees in a circle. So we're going to go a little more than that, okay? So we're going to come around here, maybe down to there, let's say, and draw our terminal side. This angle is 210 degrees, okay? Keep in mind, there's a lot of ways that you can look at this, right? I said, well, 180 is half the circle. Each quadrant is 90 degrees, okay? Each quadrant is a right angle. If we draw a little coordinate plane over here, that's 90. That's 90. So in total, you've gone 180. That's another 90. So this is 90. That angle, this angle would be 180. This would be 270. 180 plus 270. And then all the way around is 360, right? We know that. Okay, let's try letter B. We're going to go negative 48 degrees. So here is our positive x-axis. We want to go in quadrant. So we're starting here. We're going to go clockwise because it's negative 48 degrees, about halfway through this quadrant, give or take, as best we can. So let's go to there, I'd say. And there's our terminal side. This angle is negative 48 degrees. That's what we sketched out. In letter C, I want to go 405 degrees. Well, what does that look like? Okay, because let's be honest, that's our positive x-axis. If we go all the way around, that's 360, right? So what is 405? Well, 405 is the 360 and 45 more. So halfway into quadrant 1 after we go all the way around. So we're going all the way around and then halfway, and that is our angle. All the way around plus halfway through the first quadrant is 405 degrees. And then letter D, negative 290 degrees. So here we have our positive x-axis. We want to go negative 290. Okay, so if we're going clockwise, that's negative 90. That's negative 180. That would be negative 270. So we want to go just into all the way around here, negative 90, negative 180, negative 270, just a little more. That angle all the way around is negative 290 degrees. Okay, so that's how we draw angles in standard position. Depending on whether or not the angle is positive or negative, that's the direction that you have to move. All right? Okay, so now that's degrees. But let's talk about radians. So radians is another way to measure angles. Basically, if you were to take a calculus course, all of calculus is done in radian measure. We don't work in calculus in degree measure at all. Okay? So radians is an important measure or way to measure angles that you're going to learn and we're going to be working with the whole time all the way through. All right, so let's talk about radians and how they measure up to degrees. We know that a circle is 360 degrees. And up until now, we measure angles using degree measure. But we can also measure angles in radian measure. Okay? Just like, for example, we can measure distance in miles or kilometers or feet, right? There's a lot of different ways to measure distance. There's also different ways to measure angles. Okay? Radians measure angles using the arc length of a circle with radius 1. So imagine you had a circle. Let's say this is the radius, right? Let's say the radius was 1 unit. Here was my circle. Oh, that's not a very good circle. Okay. All right, let's try again. That's a pretty poor circle there. I'm not a circle drawer. All right, well, that's a little better. Okay, we have a circle of radius 1. Okay, the circumference of a circle, we know how to find the circumference. It's 2 pi times the radius. All right, 2 pi r, 2 pi times the radius. That's the circumference of any circle. So if the radius is 1, then the circumference of this circle is 2 pi times 1, which is 2 pi. Okay, so this is 2 pi radians. That's the circumference of the circle, 2 pi, right? Okay, so this angle would be 2 pi radians all the way around. Okay, but we know in degrees, that's 360 degrees. So 2 pi radians is the same as 360 degrees. Okay, so now here's how we convert. If I divide by 2 on both sides here, pi radians is equal to 180 degrees. Okay, pi is 180. So halfway around the circle, a semicircle, halfway around is 180 degrees, or pi radians. So to convert from degrees to radians, you're going to multiply by pi over 180 degrees. Okay, pi divided by 180 degrees. To go from radians to degrees, you're going to do the opposite ratio, 180 degrees divided by pi. All right. You're going to see soon enough that radian measures tend to have pi in their measure, okay? And their pi measure is usually, most of the time, in the numerator. So you always want to put pi in the numerator to knock out the degrees. That's already there. Okay, so let's take a look. This is how you convert. These are important. Here we go. Let's try to convert. Let's try to convert from degrees to radians. I want to go from 270 degrees to radians. So to do that, I'm going to multiply by pi over 180 degrees. Okay, think about it like this. You want the degree symbols to cancel out. All right. So that's 270 pi over 180. But this reduces. 90 goes into both. Zeros go in. You can knock the zeros out. That would give you 27 pi over 18. Then 9 goes into both. That's 3 pi over 2. That's my answer. 3 pi over 2 radians. Okay. 100 degrees. 100 degrees. Multiply by pi over 180. You want to knock the degree symbols out. That's 100 pi over 180. The zeros drop out. That's 10 pi over 18. And then 2 goes into both. 5 pi over 9. That's 5 pi over 9 radians. Negative 135 degrees. So negative 135 times pi over 180. Knock the degree symbols out. That's negative 135 pi over 180. Now, I know 45 goes into both. You may not, but you will soon enough. Okay, 45 goes into both. I think goes in 3 times there and 4 times underneath. And don't forget that negative sign. It's important. Okay, we know that negative sign is important, right? We just did a slide a few slides ago on negative angles, you go clockwise. Positive angles, you go counterclockwise. So if you write 3 pi over 4, well, you're not even in the right place. That's not the right angle. That's not the same angle as negative 3 pi over 4. They're 2 different places. Okay, and then 480 degrees, 480 times pi over 180. Cross out the degree symbols. 80 over 180. Zeros drop out. 48 pi over 18. Let's see. We got 2 definitely goes into both. 2 goes into 18, 9. 2 goes into 48, 24. So that's 24 pi over 9. Okay, radians. And there's my answers. All right, let's try the other way. We're going to go from radians to degrees. 3 pi over 4. We're going to multiply 3 pi over 4 by 180 over pi. So the pi's knock out now. And then we get 540 over 4, which if we clean that up is 135. 135 degrees. Negative 7 pi over 6. We're going to multiply by 180 over pi. Cross the pi's out. So that's going to be, let's actually cross cancel. 6 goes into 180, 1. 6 into 6, 1. 6 into 180, 30 times. Negative 210 degrees. Pi over 2. Pi over 2. Let's multiply by 180 over pi. Pi's drop out. 180 over 2 is 90 degrees. And pi over 3, multiply by 180 over pi. Pi's drop out. 180 degrees over 3. That's 60 degrees. There's our answers. 4 answers right there. Okay? That's how you convert degrees to radians, radians to degrees. It's really important that you can do it. You're going to have to do it a lot. All right, next, let's talk about coterminal angles. Let's go ahead and sketch the 3 angles below. Let's try to sketch 60 degrees. So remember, there's our positive x-axis. 60 degrees is about 2/3 of the way through quadrant 1. So this angle is 60 degrees. Let's try 420. So 420 degrees. Well, 420 is more than 360. So 360 is all the way around. All the way around is 360. So if I take 360 away from this, that's 60. So now I got to go 60 more degrees. Okay, that's my angle, 420 degrees. There it is. And negative 300 degrees. So here's my positive x-axis. Negative, I'm got to go clockwise. I got to go this direction now. So that's negative 90. That's negative 180. That's negative 270. And then I got to go 30 more. So negative 90, negative 180, negative 270, and 30 more. Negative 300. Now, if you look at all three of these angles, what you hopefully can see is they all end or terminate in the same place, right? 60 degrees, 420 was all the way around, then another 60 degrees, but that puts you at the same place that you were for 60 degrees. And negative 300, well, negative 270 is up to here. You have to go 30 more degrees. This is 30 more to get to negative 300. That means that this angle here would be 60 to fill out the 90. So they all end up in the same place. They are coterminal angles. Co, the prefix for together, terminal, end. Okay? They end together in the same place. Coterminal angles. All right. So again, all three of these angles have the same terminal side. We call them coterminal angles. To find coterminal angles, think about what they are. They are angles that terminate or end at the same place. Okay? How can we find coterminal angles? Well, let's say I wanted to find a coterminal angle of, I don't know, let's say 50 degrees. Okay, here's my angle, 50 degrees. 50 degrees. I want to find another angle that ends up in the same place. Well, one way to figure out an angle that ends up in the same place is literally go all the way around the circle back to where you started again. Right? Or let's not show it like that. Let's show it like this. Here, I think this is easier to see. Here's 50 degrees. You want to know how to end up in the same place? Well, start at where you stopped and go all the way around. But how much does it take in degrees to go all the way around? 360. So I'd have to add 360 to this. So then 410 degrees is a coterminal angle to 50 degrees. Well, what if I added 360 to 410? Now I'm at 770. That's also coterminal to 50 degrees. Because now you're just going to go from here and go around another time. Okay? But what if instead of going counterclockwise, I went clockwise, this way? But then I'd have to subtract 360. So if I started on 50 and I subtracted 360, I'd end up at negative 310. That's coterminal. Through negative 310 is coterminal to 50. It's coterminal to 770. It's coterminal to 410. So to figure out any coterminal angle to a given angle, you add or subtract 360 degrees or 2 pi, depending on whether or not it's in radians or degrees. Remember, 2 pi is one full revolution, one trip around the circle, 360 degrees. Okay? So let's find one positive coterminal and one negative coterminal angle to each of the given angles. Negative 500 degrees. So one positive and one negative coterminal angle. Well, I'm at negative 500. So there's a couple things I could do. If I subtract another 360 off of that, I'm at negative 860. That's coterminal. Negative 860. That's a negative coterminal angle. But I also could have done this. Negative 500. If I need a positive coterminal angle, I'm going to have to add 360. That's going to give me negative 140. That's coterminal also. That's a good answer. It's another negative answer. But it's still negative. I got to get a positive one. So I got to add another 360, go all the way around again. That's 220. That's a positive coterminal angle. So both of these are negative coterminal angles. That one's a positive one. Okay? Now, 5 pi over 6. We're in radians. So remember, 360 degrees is the same as 2 pi. Remember, 2 pi is 1 revolution around the circle. Okay? So 5 pi over 6. I want a positive coterminal angle. Well, let's add 2 pi to that. To do that, I'm going to have to make a common denominator to add fractions. So 2 pi, multiply top and bottom by 6 is 12 pi over 6. So that's 17 pi over 6. That's a coterminal angle that's positive. Now, if I go back to 5 pi over 6 and I take away 2 pi, multiply top and bottom by 6, I need a common denominator. 5 pi over 6 minus 12 pi over 6 is negative 7 pi over 6. That's a coterminal angle. That's negative to 5 pi over 6. Okay? That's all we're doing to find coterminal angles. We're adding or subtracting 360 or 2 pi from our angle that we started with. All right. Back from shapes class. Complementary and supplementary angles. Two angles are complementary if their sum is 90 degrees, or in radians, that's pi over 2. Okay? 90 degrees multiplied by pi over 180. To convert it to radians, 90 pi over 180. Zeros drop out. That's 9 over 18, which is 1/2 pi over 2. Two angles are supplementary if their sum is 180 degrees, or pi radians. 180 degrees is pi radians. We talked about that earlier. Okay, complementary and supplementary angles. All right. So now, arc length and length of a sector. Okay. Arc length is the distance around a circle. It's like the perimeter of a circle. Okay. The arc length formula, S represents the arc length, is equal to r times theta, where r is the radius of the circle and theta is the measure of the angle in radians. Okay? It has to be in radians. If it's in degrees, you have to convert it. The area of a sector is like the area of one piece of a piece of pizza. One slice. That's the area of a sector. The area of a sector is r squared times theta, where theta is the central angle. This is the angle theta here. Okay, that's the angle theta. All right, that's the central angle. Theta is the central angle measured in radians again. Okay, so real quick, let's find the area of a sector of a circle with radius 4 and central angle 120 degrees. Here's what that would look like. Here's a circle. 120 degrees. That's 120. The radius is 4. The area of the sector of the circle is 1/2 r squared theta. So the area is going to be 1/2 4 squared times theta. But theta is 120 degrees right now. We can't write that. We need to put it into radians. So we got to multiply by pi over 180. Zeros drop out. 12 pi over 18. 6 goes into both. It's 2 pi over 3. So it's 2 pi over 3. So the area is going to be half of 16 times 2 pi over 3. Half of 16 is 8. So that's 16 pi over 3. That's my area. Okay? And again, you can multiply that out in a calculator. 16 times pi, your traditional pi, 3.14. Okay, and divide by 3. The arc length of the circle, with radius 7, central angle 30 degrees. So here's my central angle, 30 degrees. arc length is this length, the length of this portion of it, the perimeter. There it is. S equals r times theta. The radius is 7. The angle is 30 degrees, but that's no good. The angle has to be in radians. So cross the zeros out. 3 over 18 is 1 over 6. That's pi over 6. 7 times pi over 6 is 7 pi over 6. That is the arc length. Okay? And that's it. All right? That's how we measure angles, degrees and radians, a bunch of different things with them. Okay? And as always, thanks for clicking.